Well, welcome everybody to one of our first presentations of the day. I'm happy to announce that Royce Davis is going to be presenting right now. I have to be honest, I'm a big fan of his work, follow him, everything he has been doing in terms of contributions to the Metasploit project, his blog posts and everything. So I'm really happy of having Royce Davis right now presenting here. In fact, I found out his name today because I already know him as Reddy and always known him as Reddy to his handle on Twitter. So Royce, take it over. Take it off.
Good morning. Thanks a lot for coming out, guys. Just give you a little bit of information about myself. My name is Royce Davis, and I'm a penetration tester. I work for a company called Labs. I specialize in mostly NetPen, red team, social engineering, those types of engagements. I also co-founded a website called pentestgeek.com. Some of you may have seen some of our articles there. I wrote a tool called Jigsaw.rb, which is an email harvesting script. And I sometimes lurk on various Twitter feeds and IRC rooms under the handle Reddy. So here's what we're going to be talking about today. The kind of synopsis of the talk is really related to owning computers without shell access. So uploading binary shells is no good. And I don't mean that strictly in 100% of the cases, but I think that it shouldn't be your go-to choice for compromising the system when you're on a penetration test and your goal is to kind of world domination, so to speak, on the network. I think we can be a little bit more stealthy and a little bit more efficient, and that's kind of what the purpose of the talk is about. So we're going to talk about some techniques that you can do to avoid uploading shells and still accomplish the same task that you were hoping to with the shell. And I'm going to demo some Metasploit modules that I've written to kind of help do some of these things. A few of them are already in the Metasploit framework, and some of them are pending approval from the developers.
I would like you provide a presentation
Yeah, so what, the other thing that I'm going to do, I will provide slides available. I'll put them up on Pentest Geek after the conference, and I also plan to do, since we're not recording, I plan on doing a separate recorded version of the talk, or maybe someone with the camera is recording. So at any case, you guys will have an opportunity to look at some of the slides afterwards. And then if everything goes well, the demos will work and we won't have any problems with that, so you guys will actually get to see it. And you won't just have to listen to me talk for 50 minutes. So before we dive right into the content, I think it's a good idea to provide a little bit of background story as to why we're even talking about this and, you know, kind of, you know, what was the purpose for the misspelling in the slides, number one, and number two, for just kind of where this came about. So if those of you who are familiar with penetration testing, if I can paint a picture in your heads, imagine yourself identifying a system on a network with some type of low-hanging fruit vulnerability. It's a missing patch or misconfiguration, and because of that vulnerability, you're able to gain access to the local administrator hash on that system. This is how, you know, most network attacks start, right? And of course, the very next step in the process is to take that local administrator hash and pass it across the network to as many systems as you can to find out how many other boxes you can access. And sure enough, lo and behold, you come to find out you have the keys to the kingdom. You can log into 1,000 systems across the network. So typically, probably for most of you, the next step in this process is to start kind of PSExecing the crap out of the network, you know, popping interpreter shells from box to box. And what are you looking for? You're looking for a system that has a domain administrator or another privileged user logged in that you can compromise their credentials or their privileges to kind of escalate your privileges on the network. Unfortunately, and sometimes, at least using just the default tools that are built into the Metasploit, sometimes this process doesn't work because what's happening is your interpreter shell is getting flagged by the AntiVirus on the target. So what do you do now? Obviously, if you're a skilled pen tester, this isn't going to stop you dead in your tracks. There's things you can do to get around this, but it does require more work, or at least more effort than you had initially started to. And this is a problem that some of us face. So kind of the first solution that came around to this problem, enter a tool called SMBexec, which is written by Eric Milam, who's here today. And SMBexec is really cool because what it does is it allows you to bypass the default payload that's built into Metasploit and actually custom build your own binary executable using whatever methods you like to package your binary to bypass AntiVirus, and then it actually uses that to get an interpreter shell on the target. And the other cool thing that it does is it adds functionality to target multiple systems at a time. So at this stage, this is a wonderful solution to this problem, and really takes you, one step closer to compromising the network. That being said, as great of a tool as SMB-exec is, it does still rely on uploading a binary shell to the target. And what I want to talk about today is why I think uploading shells is not necessarily the best idea. So, what's the reason for that? We've been doing it since, the birth of computer hacking. Why should we stop uploading shells? I think there's a couple of reasons. The biggest one are binary signatures. Your binary payload contains signatures that can be flagged as malicious. They can be cataloged by an antivirus or an intrusion detection system, and they can be stopped. You can obfuscate your payload, but you're doing that is not removing the signature from the application. It's still there, it's still present. And then you sort of start this cat and mouse game with the antivirus vendors where, one day your payload walks past them and then they flag your payload, create new signatures, and you have to re-obfuscate it and go on and so forth. Not only that, shells can die on you and leave no way back into your target. Some of you have been in a situation where you've exploited a vulnerability, you've gotten a shell, and that works because when you exploit a service, your shell code is running in memory, so the antivirus most of the time doesn't touch that. However, trying to Psexec in other boxes doesn't work, and you forgot to create a backdoor in your first shell, and then when it dies, if it's an exploit like, for example, MS08067, where the server service is now rendered unexploitable after that failed session, you're out of luck. And lastly, shells, they make a lot of noise on the network. They can drop files on the system, and even if they're supposed to clean it back of themselves, sometimes they don't. They cause alerts. They can be used to, these remnants can be used to forensically track back to your system. And if the goal of the penetration test is to be stealthier, to avoid detection, popping a shell in a box could turn out to just cancel the whole thing. So I think the industry standard solution to the problem of bypassing antivirus right now, and the commonly accepted is well, you got to be better at obfuscating your code. And I think that's really cool, but I think that we could also accomplish some of the same things without using a shell at all. So if we're going to talk about that, it's probably a good idea to identify first what are some of the reasons why we upload a shell in the first place. What goals are you hoping to accomplish, and what additional features and functionality do you gain by uploading a shell? Well, in today, penetration testing, that's a large laundry list. I mean, with shells like Interpreter, the amount of things that you can do, the functionality that it adds is huge, and I'm not here to say that that's not awesome. But I think that the majority of the functions can probably summarize into just a couple of categories. And the first one is absolutely command execution. That's the whole reason why you upload a shell on your target. You want to interact with the operating system's kernel. You want to send operating system commands to the target to do any number of things. Look for sensitive files with potentially juicy information on the target. Query network resources or enumerate additional information about your system. Create, modify existing users. Upload, retrieve files. The list goes on and on. Command execution is probably the number one goal. And in penetration testing today, I think obviously a number 2 goal is to achieve or to gain password hashes to both local and domain cache credentials on the system, because pass the hashes become such integrated with what we do. In fact, in the few instances where I'm presented with a network where the 1% of the people out there that actually stop pass the hash entirely, I'm scratching my head sometimes, going, trying to think of new ways to compromise the network. So. And are there any others? Of course, we could be here all day and talk about all the reasons, but I think that probably summarizes a lot of the things that we can do. So the good news is, it turns out we can do all this stuff using native functionality that's built into Windows. And what I'm talking about are DCE RPC, or remote procedure calls over the MSRPC. These give us access to all the APIs in Windows. And if we're passing the hash, and it's the administrator hash, well, we now have full access to any of these APIs. So there are already some tools in Metasploit that are starting to do this. I want to see more. The perfect example that we're going to talk about, and this is kind of the code that I used a lot when I was building my modules, is the Psexec module. It's a great tool. What it does, if you're not familiar with it, the inner workings of it, and I'll be honest, I really wasn't before I started this project. I just used it, it worked, it was great. But essentially what Psexec does is it interacts with the server control RPC handler on a Windows system. It binds to it by targeting the specific UUID 367ABB, whatever. And it then runs a series of functions that are accessible from the SBC CTL library or the Windows API that's bound to that server handler. So it uploads a binary, creates a service, starts it, stops it. I put a link in the slide to the MSDN documentation to take a look at the various functions that are available. But we can actually take a look at the source code to the Psexec exploit module, and we can actually see if we search for the DCERPC.call method. .call is an instance method of the DCERPC object. It takes two parameters as its execution. The first is an opcode representation of the actual Windows function that you want to call from the library, and the second parameter is nothing more than the parameters to that function wrapped in an NDR formatted packet. And we can see sequentially the calls that Psexec makes to open SC Manager, create service, close service handle, open service, start the service, delete the service, close the service handle. So a lot of the stuff that we're doing is really interesting magic that's just using the native Windows functionality. The only difference is if we look at the code on line 254, we can see this variable file location. And HD Moore, who wrote the module, put a nice comment in there for us. This is a binary path. So if we cross-reference that with the Microsoft definition of the create service function, we can correlate that with the vulnerability, or I'm sorry, with the variable LP binary path name. And we can see that that file path is being passed to that variable. So if we dig a little bit deeper, we get the information about what this variable is. It is nothing more than the fully qualified path to the binary on the remote system that the create service function is going to spawn its service off of. And we can even see that we can send arguments to this service. So we could potentially extend the functionality that Psexec isn't even doing right now. We could even target an executable on a remote system, if we see it in the third paragraph. But just with the standard Psexec exploit module, we can see it probably looks something like this. It's spawning a service off of C:/ and then some random 16 or 24 character string file.exe. That is your evil, malicious file. And it's nothing more than a pre-computed payload using the standard, encoding practices that are in Metasploit, and they're great, by the way, but let's be honest, everybody uses Metasploit because it's such a powerful tool, and as a result, antivirus vendors are, very aware of the signatures, so oftentimes this will fail. So if we're going back to the topic here of owning computers without shell access, what we have to ask ourselves is what if we could replace that random malicious executable and don't upload anything to the target? What if we could target a binary that already exists on the target, like cmd.exe? This is baked into Windows since Windows 2000. It's in Windows Server 2012. It is a part of the operating system. It's something that a system administrator would use on a normal day-to-day basis, so the likelihood of it ever getting flagged by an antivirus is very, very little. And because the LP binary path name definition tells us that we can pass parameters to the executable, we can now change the command. So instead of call the binary, we call cmd.exe/C as a parameter, and then the value that we pass to /C is echo this Windows command into a batch file, and then we use the ampersand to do a second command to actually use cmd.exe to start the batch file. So essentially what we've done here is we've done a directory listing of the C drive and put that in a file called outputfile.txt. And then we call that. Now we just have to retrieve outputfile.txt and we get the output from our command. So basically what we built here is a non-interactive shell. This is the same thing that we've been doing for years with PHP or web vulnerabilities, where you upload a bit of PHP code to a website. You can send one command at a time. You click enter, you see the output. You click enter, you see the output. It's not interactive, but it's extremely useful to do just about anything that you could. All the things that we listed before, looking the file system for information or modifying users, we can all do this. So the first module that I created is called psexec_command to do just this. Now, when I initially started this project, the path that I took was probably not the best. I basically took some code from the Psexec module, wrapped it in a function, modified it a little bit to fit my needs, and then just copy and pasted that into all the modules that I was writing. And the Metasploit developers came up with the great idea that we should actually put it in a mixin. So what I created is the lib msf core exploit smb Psexec Mixin. So this is baked into Metasploit now. So any of you who happen to have skills in developing modules for Metasploit, you can have access to the functionality, and you can now start running Windows commands in your modules without even having a Windows shell. And the Mixin is very simple. It has two methods. The first is called Psexec. It takes one parameter as a string, which is basically formatted like this: the path to CMD /C, and then insert Windows command here, whatever do you want to run on the target. And then because this is non-interactive, if you do want to see the output of your command, you have to put it to a text file and then retrieve it. Now, some of you may be thinking, I thought we were owning computers without uploading anything to the target, without touching disks. And what I say to that is a text file or a batch file is ASCII data. There are no machine language instructions in this file. No antivirus is going to read that there's a text document that says I'm hacking the network. Nobody's going to read that and throw up a red alert. So we're definitely moving in the right direction here. So we'll go ahead and move into the first demo. First, we'll just take a quick peek at the source code. It's pretty small. It's only 3 methods. And I'll talk about some of the uses that I find valuable on a pen test. And I use these on every one of my pen tests, and I can tell you that it's really sped things up for me and really proved to be quite useful. And we'll go ahead and demo the module. So by the way, I just have a couple Windows VMs, Server 2008, domain controller, just a regular Server 2008 and Server 2003 set up. So if you take a look at the source code to the Psexec command, we can see all the includes that we're doing. We're using DCRPC because we have to in order to interact with the server control manager handler. We call the Psexec Mixin that we created. And then I call scatter because all the modules that I've written are auxiliary modules. So you can target an rhost's range, a list of IP addresses, and using the native threading capability that's already built into Metasploit for you, you could run a Windows command on 1,000 different computers in about 4 minutes. So it's really powerful. So it's pretty simple. If we take a look at the run host method, we simply declare a string, which is the path to our text file, and our batch file, which we're going to upload to the target. We're going to store it in the Windows temp directory.
Can you increase the font size?
Oh, sorry about that, guys. Tell you what, how about I throw up a link to the source code a little bit later on. I'll just demo the modules. I'm just going to walk through and tell you guys what's doing. If you guys are coders, you want to actually look at the code. Some of you guys are looking at the code and you're like, who cares? So I'll provide access to the code for anybody who wants to actually see it. It's on my GitHub page. But essentially, we declare the path to our text file and our batch file. We then connect to the host on port 445. We authenticate with the password hash that we've passed. And then we run the execute command method, which takes the text file and the batch file. And here's what the execute command looks like. We create a string called execute, and we put the variable comspec, which is a Windows environmental variable, which is the path to cmd.exe. And then we echo, and then data store command. That's the variable that you, the user of Metasploit, specifies. So whatever command you type, it's going to put that here, put the output on the text file, and then output that to the batch file and run the batch file. And if it returns true and the command was successful, it simply runs the get output method, which just goes in and connects to the target, runs the SMB read file, and actually reads the output, prints it out to your screen. If the output was blank, it just says the command complete without output. And then finally, it just runs the cleanup after method. It just deletes your text file and deletes your batch file from the target, so you're left with no traces. So it's pretty straightforward. I don't know if everybody can see that, but here are the parameters that we pass to the module. We pass the command we want to run. By default, it's the command to query the domain admins, which is really the first command that I run on any pen test when I compromise a system, because I want to know who are the privileged users, because I want to go after systems that those users are logged into. So that's typically the first one that I'll run. We specify an rhost range. We can give it a single IP. We can give it 1,000 IPs, whatever. Now, I've got a username. I've got a password in here, but this is the default SMB authentication that's built into Metasploit, so this could just as easily be a hash and it still works just fine. So I'll run that on the 2 IP addresses. We can see it's executing the command, it's getting the output, and basically what we see here is 2 different outputs. So it authenticated to 2 systems, it ran the command, it spit the output out, now we know who the domain admins are. So where do I go from here? Earlier in the year, some of you may have seen I put out a Metasploit module called Psexec_logged-in users. The purpose was to scan a range of hosts and identify what users are logged into those systems so you could target the proper IP address that had a domain administrator logged in. Unfortunately, when I was building the module, I did factor in the various different service packs and various different versions of Windows have different registry key values to display the current logged in users. So some of you may have used the module and thought to yourself, wow, this is great, this is amazing. Others of you may have used it and said this doesn't work. So while I'm in the process of refactoring that code, the psexec command module is actually great because I simply run the qwinsta command. I'll show you what that looks like. qwinsta is just a command baked into Windows that displays information about the current active session. It displays the username, the type of session, if it's a remote desktop session or a console session. So I'll run this on all the systems that I have access to, and then now I have a Metasploit spool file with the output, and it's obviously a pretty big output if you're running this on 2,000 systems. And then just grep for the domain admin, and now I know exactly what box he's logged into, and I haven't had to go in and pop shells to find that system. So right off the bat, if this is all we're using, this alone has made pen testing for me much more efficient. And obviously, we don't need to demo it because you guys get the point, but some of the other uses are creating users. Sometimes I like to create a local admin user on a system just so that I always have the backdoor. I can RDP into that and access Windows graphically. There are sometimes cases on a pen test where that is kind of a legitimate use case and it proves useful. Querying shares on the system, finding what servers are hosting the data, right? Where's HR backups or whatever have you. So there's a lot of use cases for it, and if you guys haven't already played with the module, this is in Metasploit, so feel free to check it out. It's pretty useful. So that was command execution. The other thing that we talked about as a major use for uploading a shell is gaining access to the password hashes. Now, currently, you really have two common ways of doing this. The first is to use a post module in the framework, which they all work great, and they're very reliable. You do have to have them interpret a shell for this to be successful. Another option is kind of a little bit more old school, upload a standalone Windows binary to the target like pwdump or fgdump or whatever have you, and extract the hashes from the system on the box. So you'd have to somehow execute that Windows command system, so you basically have to have a shell for this to work too, or a clear text password that you could log into RDP. Both these methods work in the same manner, and what they do is they attempt to extract values from registry keys that are loaded into Windows, they're loaded into memory, and they then extract the password hashes from these registry keys. The problem with that is that this process can be detected by heuristic analysis, and although heuristics hasn't come as far as some of the antivirus vendors would like to promote, it is getting there, and there are systems that can flag on this. I have seen it happen. So what we need to do is we need to figure out how to get a copy of the necessary registry hives, pull them offline on our attacking system, and now we can extract whatever data we want from them, not just password hashes, completely free from detection of antivirus and also completely free of affecting the state of the system that we're attacking. So to me, that sounds like a much better alternative. So when I think about doing this, this kind of comes to mind, this old school attack when the Backtrack Linux live CD was first becoming popular. If you had physical access to a box, you could reboot it into Backtrack, and then you could mount the Windows partition. And once you mounted the Windows partition, the secure files that are normally protected by the operating system, it's just static data. You can retrieve the files, manipulate, and do whatever you want. And there was a Python script called pwdump.py, which is actually part of the cred_dump suite, that you could use to target the hive directly and just dump the hashes out of that way. And by the way, it's worth mentioning that pwdump.py is the basis for most of the code that deals with hash dumping in the Metasploit modules. So we know what we want to do. We want basically authenticate to the system, use the Psexec Mixin to run a Windows command that's going to create a copy of the registry that we want. So how do we do that? Turns out there's a tool called reg.exe that we can use to make a copy of a protected registry hive and store it somewhere on the disk, unprotected. I've talked about this in some circles, and someone always seems to bring up the fact that this will not work unless reg.exe is available on the target system. And that's absolutely true. Good news is reg.exe has been around since Windows 2000. It's still in server 2012, so it's really a non-issue. You're not going to run into a system that doesn't have this tool. So we log into the system, we create a copy of the SAM file, the Security Accounts Manager. That's where local password hashes are stored. We save a copy of the system hive because the system hive contains the LSA key value, which we'll need to use to decrypt the username SIDs into readable usernames, and also the TripleDES and MD5 keys that we'll need to use to decrypt the hashes into readable format. Because even in the registry, the encrypted hashes themselves are encrypted again in the registry using DES and MD5 encryption. We download the hives to our local system. We then extract the data that we need for them using the Rex registry library that's in Metasploit, and then we delete the files from our target. So before I demo the module, I put this slide up here because I just wanted to remember to bring up the names of a couple of people, and I don't want to mispronounce the name, but the gentleman that wrote CredDump, that source code was, very, very crucial in writing these tools. Like I said, if you go into Metasploit and you look at the hash dump module or the smart hash dump that Carlos wrote, you can actually take a look at the PW dump code and you can see that they just took that code and made it work in Ruby. And I had to do the same thing, and I had to reverse it line by line, so that was a huge process for me because I'm not a big Python guy. I don't have anything against Python, I just don't know the language. Carlos, who wrote the smart hash dump module, I looked at his code, I used a lot of his code. The thing is that I had to tweak the code a little bit because before I did this, all of these modules, these post modules, again, that require a interpreter shell, what they're using was a library that Metasploit baked in the interpreter called the session library, and then session has all sorts of different features. So you go session.registry, load up one of the registry hives from memory, and unfortunately we couldn't do that. So we needed to use the Rex reg library because we actually have a static hive that we're targeting. So I had to modify that. So Brandon Perry, who wrote the tools/reg.rb file that's in Metasploit, he was really helpful for that because he wrote a lot of the code to interact with those registry hives. So let's go ahead and go to the demo. I don't think we need to review the source code. You guys can get that code on the internet if you want to see it. So the first one we'll do is the hash grab module, and again, this is a scanner module. You can target multiple systems. This is a really useful feature on a pen test because I often find just random boxes on the network that the sysadmin created a local admin user on for whatever reason, because he had to do something on that specific box and maybe made the password the same password that he does for everything. So oftentimes what I'll do is I'll do two things. After I pass the local administrator hash, and let's say that doesn't work on some systems, I'll find all the other local user accounts, and I'll pass all those hashes as well, and I'll also replace the username with administrator, and I'll try all those. And I script it out, and it's pretty quick and easy, and a lot of times I've actually found like the master domain admin password that just was the same password on some Windows machine. So we can see hashdump logged into 1.41 or 1.100, and it logged into 101. So we have the John the Ripper style format of the username, the colon, user ID, colon, and then the password hash. So this is the exact same format that you'd get if you ran hashdump or smart hashdump. The difference is, guys, we don't have an interpreter shell on the target. We just passed the hash into the box and got the hashes. So I think this is really cool. I think this is really useful. We'll talk about cache grab for a second because this is a technique that is rather new to me that I've learned to be quite useful. Obviously, we know, or at least we think, that domain cached password hashes cannot be used, to pass over SMB. But one thing that can be done is run against a dictionary file using John the Ripper or any other password cracking tool. Because this is an auxiliary module, I've been on an enterprise pen test and run this module on 2,000 workstations, just workstations, not servers, and literally got a list of 500-600 Active Directory passwords. Now think for a second. A lot of these guys are users. They maybe don't have the same idea around strong passwords as some of the sysadmins do. So if you have a decent dictionary file, the rocku.txt file is good for starters. You can break a lot of these passwords in seconds. And what I find is that when you get Active Directory passwords, sometimes you can find a user that for whatever reason has administrative access to one server because he is the database guy and he's needs admin access to stand up this test database server. But the server was installed with the same image that all the other servers have, so now you can dump the server admin hash and now own the network. So this is really useful in that situation where there's one admin password for the workstations, one for the servers. You've got the one for the workstations and you're just trying to find a workstation that has a privileged user. This is a great way to not even compromise the system, not pop a shell in the box, not affect the state of your target system at all, but get a whole list of credentials that you can try on the network. And when you use these credentials, they're valid. So you're probably not going to even trigger an event unless they have really, really evasive event logs turned on, because this is just a valid login. Kind of flying through this, so it looks like we're going to have a lot of time for questions at the end, so you guys better be writing down your questions. So the last module that we're going to demo is one that we can use to get into the domain controller and access the NTDS.dit, which is an ESE or Extensible Storage Engine database that is stored on a domain controller. This database contains a slew of information about Active Directory, including all of the password hashes for all of the Active Directory users. So this is a protected file from the operating system. Even if you're logged in as system, you can't access this file without doing some magic by migrating into LSASS process, or there's some things that you can do. And the post modules that are in Metasploit, they work really, really well. But the thing is that if you're on a client network, you might not want to be migrating into a critical process like LSASS on a domain controller, because if something does happen to go wrong due to network latency or an error on your part, you could be in a pretty bad situation. So it would be awesome if we could do the same thing that the post modules do, but without hurting the target or getting a shell on the domain controller. So the module that we created, that I created, is called Psexec_NTDS grab. So this module gives you a couple of options. You can create. So I'm getting ahead of myself. As I mentioned, NTDS.dit is a protected file in the operating system. So if we're not going to inject into LSASS and we want to gain access to it, we have to find an unprotected version of it. Well, there is one stored in volume shadow copies. Volume shadow copies are a common thing that you find on domain servers. And it just so happens that if you don't find one, there's a really nifty Windows tool that you can use to create them called VSSAdmin. So what we're going to do with Psexec_NTDS grab is we're going to log into the system again using the Psexec Mixin, and we're going to issue the VSSAdmin command to create a volume shadow copy. We can also tweak this to, we can just give it the path to a volume shadow copy that we already know exists on the target. If we did our, our due diligence and we used Psexec command to manually create one, we can say, hey, just check the system for volume shadow copies and find the latest one and grab it. So there's a lot of options, but the default is we'll create a volume shadow copy with VSSAdmin. We'll then run the command within the options in VSSAdmin to list all the shadows so we can get the path to a volume shadow copy. And what that path looks like, and I apologize, you can't see it on the slide, but it's /global root /device/hard disk volume shadow copy and then a number. And it's whatever the number is of the volume shadow copy. So if you're on a system that's never had one before and you create one, it's going to be 1. Once we have that volume shadow copy, we can then have an unprotected version of NTDS.dit. And let me just pause by saying that I didn't come up with this. This has been around for a while. Some of you may have read articles about this process. This isn't a new thing. I've just written the modules to do it in a new way. So we can copy the unprotected version of NTDS.dit, and we also need, again, that system registry hive so that we can decrypt the SID values of all the users into text-readable usernames. And then we download our copies, we clean up after ourselves just like normal. Now, before we demo the module, there's a little bit more that we need to do once we have a copy of NTDS.dit. This is an extensible storage engine database, and if you try to access it on your attacking system, it just looks like gibberish. It's a binary compiled file. So there's a really cool library. It's a C library called libesedb, which you can pull down from the Google code page, untar it, configure it for your system, make it install, and then you can use a whole bunch of tools in there to do a lot of stuff. Not just get password hashes, but basically the tool that we used is the ESEDB export tool, and what that does is it decompresses the database and then outputs all the individual tables. And there's quite a few tables, and there's a lot of information about the Active Directory network. As I mentioned, there are a number of articles already on the internet that describe this attack. I just put a link to an article that I wrote on Pentest Geek because I wrote a special Ruby tool to dump the hashes from the exported data table. And the reason why I did that is because the current tool that works best to do this is a tool called NTDS extract, like X with an extract. It's a great tool. It pulls a lot more information than just the hashes. What I want to do is I just want a large text file with a hash after hash after hash, so I can feed that into John the Ripper or whatever password cracking tool that I do. So I wrote a tool that's not in Metasploit yet that I'm going to demo for you guys to do this. This module was just accepted into the framework, so you guys can play with this module in your pen tests. Let's just get right into the demo. So this is the only module that's not a scanner module, because the Metasploit developers didn't want it to be. If you pull down the code from my GitHub page, you could run this on 10 domain controllers if the network is big enough. But for this module, it's just one domain controller. And that's usually all you need. So take a look at the default options. Create new VSC. I misspoke. It defaults to false. So the default behavior of this module is to alter the state of the target system as little as possible. So it's going to check and see if a volume shadow copy already exists on the target. And if multiple volume shadow copies exist on the target, it's going to find the most recent one, whichever one has the highest number, and it's going to pull NTDS.dit from that. You can set that to true, in which case it will create a brand new one from you. The other option that you can do, if you have this set to false, is you can set VSC path to the actual full-length path to the volume shadow copy that you created. So you can be pretty surgical with this module as much as you want to. So go ahead and run that. It's checking if a volume shadow copy exists. It found one. And now it's going to try and copy NTDS.dit. Now, depending upon the size of the network, this is obviously a test virtual machine in my system. I want to point out, it's important to know that this can take a long time. If it's a large volume, it's going to take a while to copy. So keep that in mind. But it's hard to see with the font, but what happened was we have two files in our MSF4 loop directory, and we have this really long name that the Metasploit developers made me put in there. And I love the Metasploit developers, by the way, so I'm not saying anything bad about those guys. Those guys are awesome. So the .dit file, that's NTDS.dit. And then we also have the system registry hive that we pulled down. So how do we get what we want out of these files? So if we cd into our loop directory, we've got a couple files because I did this a couple of times before the talk. I'm just going to blow away this directory real quick. So let's go ahead and take the most recent one. So what we're going to do, if we run the tool that I created, it's in, oops. So I put it in the tools directory. It's called NTDS_hashgrab or hashextract.rb. If we run that with no arguments, it'll tell us how to use it. So all it expects is two parameters. The first is the data table. Remember what I said, NTDS.dit is a compressed binary database. We need to extract it. There's a bunch of tables that we list. The one called data table, that's the one that we feed it as an argument, as well as the system hi file that we extracted, and that's going to print out all the hashes. So if we run that tool, oops, I'm getting ahead of myself. We don't have the data table, we just have the compressed database. So here's where the libese db library comes in handy. We're going to use esedb export. You can see why I don't like this really long file name, but whatever. So we target that, we can see that it's exporting all the various tables, and if you just look at the names of the tables, MS, sysobjects, object shadow, there's a ton of information in here, not just password hashes. So we need more people to play with this stuff and kind of explore this and write tools to find the cool stuff that we want. But we can see here that the fourth table is the data table. That's what we want. So what esedb export did is it just created a directory for us with all the exported tables. So we'll take a look at that. So we'll run the tool. So again, it wants two arguments. The first, the data table. The second is this .bin file. That is nothing more than a binary copy of the system registry hive. Oops, I can already see an error in my command. So we'll run that. Takes a second because, and it's obviously going to take much longer if this is an actual enterprise Active Directory, but we can see here, we've now got all the password hashes to all the users. So, I mean, the reason why this is really cool, again, if we're continuing on the preference of owning computers without shell access, if you think about what we've done here, we popped one box in the beginning of the pen test with MS-8067 or whatever we found. We then passed that hash across the whole network, found out exactly where the privileged users were. We then extracted the domain cache password hashes from that box and used a dictionary file to crack the plaintext password of a privileged user. We then used that to log into the domain controller, export an unprotected copy of NTDS.dit. We now have all the password hashes. We only compromise one system. And why this is really cool is because if we're really trying to be stealth, we no longer have the need to go in and create our domain admin user. I know we like to do that because we like to beat our chest to the client. But if it's like a red team engagement, you're trying to be stealthy, we can just pass these hashes to any user. And now all they're going to see with our activity is legitimate logins from their domain admins. So wrapping things up, I hope we didn't go a little too fast for you guys. The purpose of the talk is that uploading binary shells is not the best way to do it. And I think that with some ingenuity, and I think with some more exposure to DCERPC and more developers realizing that these possibilities are out there, taking a look at these concepts, I think we can have a lot of tools to help us further this process. In fact, I would be so bold as to say, and a colleague of mine who I started Pentest Geek with is, we're on a project right now. Every single post module that is in the Windows directory could theoretically be rewritten to use the Psexec Mixin to accomplish its task, whatever it is, without popping a shell. We could get really stealth with this, guys. Really, the sky's the limit to what we can do if we just kind of change our style of thinking. So, real quick, any questions? Does anybody want to bring up anything? Thank you. Not yet? Okay, fine. No, I'm just kidding. Does anybody have any questions? Anybody want to tell me anything? Or did you guys like this stuff? Go ahead.
We have what would be the logic for countermeasure when we use this type of
So how to protect against this?
Yeah.
Okay, so that's a great question. So the question is, how do we? Perfect. So for everybody who didn't hear, the question is, This is really awesome. Okay, he didn't say that. It bypasses antivirus. It's totally cool. How the hell do we stop it, right? So if you guys remember from the beginning, what we talked about is this all started from a compromise of one system with one hash that we passed across the network. Stopping this attack stems from stopping pass the hash. And pass the hash is a design flaw in Microsoft that allows you to take a local account and remotely log into other systems. There's no need for that. That's what your Active Directory domain administrators accounts are for. So you should be pushing group policy to systems that say local accounts, they can't log in remotely. And if you do that, this attack is going to be pretty much stopped dead in its tracks. Does that answer your question? Any other? Go ahead, sir.
About those NTL hatch, it is working with LMH hatch directly from the Windows capture packets. Okay, what happens if you use 256 LMH hatch and you avoid that can capture hatching?
Are you asking 256 character password?
That's right.
Okay, so the question is, the demo, which by the way I demoed with NTL hashes by the way. So the question is, what if your password is really, really, really big? So the answer is, it doesn't matter. So the way NTLM hashing works is your password can be up to, I think it's actually 64 characters in NTLM, and Microsoft uses a complex mathematical algorithm to turn that string, whatever it is, if it's 2 characters, if it's 64 characters, it turns it into a string of the exact same size, which is a 32-character string. And because pass the hash is not a vulnerability, it is a design flaw in the implementation of a Windows system. The size of your password, unfortunately, doesn't matter in any way, shape, or form. Fair enough? Any other questions? My contact info is up on the slides. I thank you guys very much for coming to my talk. Thank you.